Okay, smaller pixels, faster pixels, and better pixels. Now, the first word of this is different from what most people do. Most people say more pixels. And I want to emphasize that for any given sensor size, if you're going to higher resolution, you're going to smaller pixels. And again, until we get into that era of computational imaging, smaller pixels mean less sensitivity, less contrast, less dynamic range. Yeah. So why do we want to go to higher resolution in the first place? This is a chart that actually came from ARRI originally, and it was when they came out with a 6K film scanner. So something that could scan film at a higher resolution than people had done before. And based on 20/20 vision and simple geometry, they came up with these triangles where the people even way back in the back of a cinema auditorium can still see 3K, and the people in the middle of the auditorium can see 4K, and the people a third of the way back from the screen can see 8K. But here are the 2013 top box office movies. Number 1, again, shot on film, The Hunger Games. Number 2, Iron Man 3, shot on ARRI Alexa. 3, Frozen was animated. 4, Despicable Me 2 was animated. 5, Man of Steel, shot on film. 6, Monsters University animated. 7, Gravity, ARRI Alexa. 8, The Hobbit, Hobbit Desolation of Smog, shot on a Red Epic. That's the first one that was shot with a camera that even says that it's a 4K camera. Number 9, Fast and Furious 6, shot on film. And number 10, Oz the Great and Powerful on the Red Epic again. Well, notice those Alexa movies, and then look at the right. The resolution of the ARRI Alexa is 2880 by 1620, so it's not even a 3K camera. But it makes gorgeous pictures. So resolution is not a criterion that seems to be an issue. So again, why higher resolution? There's ARRI 3K cameras less than 3K, and the top 7 movies didn't use 4K cameras. Here's something from NAB. This was at Ericsson, live UHD TV. You can't tell from this picture that it's 4K. You probably couldn't tell if you were at the show that it was 4K. The most common thing that was asked at NAB at a 4K exhibit was, is that 4K? Now, some cautions about methodology. Obviously, I cannot properly show you here resolution, frame rate, or dynamics. Source material matters tremendously. I could probably find some source material where 4K would be obvious. Viewing conditions matter tremendously, especially screen size, distance from the display, and what the display is. And there is the typical home viewing distance, nominally 2.7 meters or 9 feet. That was first derived by Bernie Lechner, who just did a study and asked people how far away they sat from their TVs. He died recently. But whatever the home viewing distance is, we have 2 issues. One, the viewer is going to have a relaxed position and an excited position, and that green thing that you see there is a yardstick. So there's about a 3-foot difference for that viewer between being relaxed and being excited. And also, when people shop for TVs, they are always closer than TV viewing. So viewing distance, again, if we had a couch in that picture, your knees would be up against the cabinet. These are some viewing figures that were released by the European Broadcasting Union at the Hollywood Post Alliance Tech Retreat in 2013. The viewing was done on a 56-inch screen. There were 6 sequences, and they used 2 viewing distances. One was that 2.7 meters or 9 feet, the standard home viewing distance, and the other was 1.5 times the picture height. Well, 1.5 times the picture height for a 56-inch screen is a little over a meter. So there's about a 2.6 times difference between those 2 viewing distances. And yet, if you look at the results, certainly there's no question people could see 4K. So it was consistent, it was statistically significant, absolutely they could see 4K. But at typical home viewing distances, it added about a third of a grade of improvement. and at this 1 meter away from the screen viewing distance, it added about a half of a grade of improvement. That's not a lot of improvement for 8 times the uncompressed data rate. We are at a SMPTE event, and I want to emphasize that it's SMPTE. The M stands for motion. So why are we even talking about static resolution like 4K? We should be talking about dynamic resolution. These 2 images were shot with the same camera. The one at the bottom is the native image. The camera was running at 300 frames per second. The one at the top is a simulation of what 50 frames per second would have looked like. You can see that the ties and the tracks have identical resolution in both of the images, but the locomotive certainly does not, because it's moving. In movies, you will often see something that I refer to as the waiter shot. You get into a restaurant and the camera follows this waiter who has nothing whatsoever to do with the plot until it gets to the table where the protagonists are seated, and then the waiter walks out of the shot and we deal with the protagonists. The reason for that is otherwise you would go nuts from the strobing that happens in 24 frame per second imagery. So here's the European Broadcasting Union at the International Broadcasting Convention last fall, and now it's different content. It's very high motion stuff, but this time they're showing that for every doubling of the frame rate, they're getting a full grade of improvement. So now we're talking just twice the data rate and getting a full grade. Before we were talking 8 times the data rate and getting between 1/3 of a grade and half a grade of improvement. Then there's high dynamic range. There was a debate at IBC on whether we need to go beyond 4K, and one of the people at the debate said a 4K display delivers the best HD you've ever seen, and this is a very common statement. But in fact, ARRI had side-by-side monitors. One was a 4K display, the other was high dynamic range HD, and even the quoted person agreed when he saw that the high dynamic range HD looked better than the 4K. High dynamic range can increase picture detail because it can reduce clipping, and consumer TVs already have much more dynamic range than reference monitors. Contrast, by the way, contributes to sharpness, and higher resolution can result in reduced contrast. So here's an early camcorder compromise. Sony started this when they came out with HD cam. The yellow curve is typical modulation transfer function for a whole camera lens rig. So contrast is increasing upwards, resolution is increasing to the right, and what Sony said in HD cam was, okay, HD goes out to 1920, we're just going to lop that off and do only 1440 in the Luma channel, and we'll do only 640 in the Chroma channel. And then Panasonic did something similar with DVC Pro HD. So significant loss of resolution, but very limited loss of sharpness, because sharpness is proportional to either the area under the curve, if you're a believer in the Zeiss school of thought, or the square of the area under the curve, if you're a believer in the RCA school of thought. Either way, it's the area that matters. So if we can increase that area, even just down at the bottom end, at the high resolution end, we're adding tremendously to the area under the curve. And if we can increase the whole area by increasing the brightness of the display, giving you more contrast, then we're adding huge amounts of sharpness. And it doesn't matter if we add any resolution. And nobody watches TV and says, my, what resolution that picture has. Some people say, wow, look at how sharp that picture is. Sharpness is a psychophysical function that involves contrast. So, how much data increase does high dynamic range require? Theoretically, none, because bit depth simply determines signal-to-noise ratio, about 6 dB per bit, as long as 1/2 of the least significant bit is noise. Practically, because nobody deals with that, it causes contouring, as you can see here. Contouring is halved with each additional bit, and it's eliminated when you have enough bits that the noise, again, is 1/2 LSB. So let's say that we had to go from 10 bits to 12 bits. That's an increase of 20% of the data rate. And let's say that high dynamic range increases things only half a grade. That would still be 0.4 times the data rate to get a full grade increase that's better than what we had for either higher resolution or higher frame rate. So sure enough, at the SMPTE Technology Summit on Cinema at NAB, here was one paper. There were actually two papers that were presented on this. One was from the EBU. The EBU didn't want me to show their figures because they say they're still massaging them. But here's the Swiss Federal Polytechnic Institute, and they say that their numbers are very, very close to the EBU numbers. And basically, as the brightness of the display increases, we get tremendous improvements. So Dolby was showing Dolby Vision. They're one of 4 groups that were showing things at the show, or that are pushing things related to high dynamic range. Technicolor, BBC, and Philips are the others. 100 nits is what the reference monitoring standard is. 4,000 nits is what this new Dolby prototype display puts out. Obviously, I can't show you that here. But down at the bottom is a commercially available Samsung display, and it puts out 1,500 nits. And ordinary TVs put out between 450 and 900 nits. So we're doing reference monitoring at 100 for consumer devices that are going between 450 and 900. But there's interactivity between higher resolution, higher frame rate, and higher dynamic range. So let's start with the chart at the lower left. If I have a 720p image and I have it on a screen and I have something moving from one side of the screen to the other side of the screen, if I allow 10.7 seconds for that thing to move from one end of the screen to the other, I have no aliasing. So it will appear in 1 pixel in every frame that goes along. Now look at the upper right of the chart. If I shoot 4K at 24 frames per second, it takes 171 seconds for something to move across the screen unaliased. And that's why we have the waiter shot, because we have terrible aliasing in film. Now look at the diagram at the right. This is taken out of something that appeared in the Journal of the Society for Information Display. The stuff that you want is within the red oval, which I've added. That's your unaliased information. All of the other lines that you're seeing are aliases because there is not sufficient frame rate. And so as you add more frame rate, those lines widen out and eventually they go outside the circle. The circle is things that you can see. But notice that some of the stuff is nice solid black and some of it is very light gray. Well, here's where high dynamic range enters the picture. So Dolby was showing, as part of its Dolby Vision demo, beautiful footage of some old cars with lots of chrome coming out of a dark garage into bright daylight, and the speculars off of the chrome were absolutely magnificent. Some of the best looking images I've ever seen, except that the motion judder was worse on the high dynamic range ones than it was on the low dynamic range ones, because of this visibility, because you're making the stuff blacker rather than lighter. Wider color gamut. The image that I'm showing you at the upper left is something that was shown at the HPA Tech Retreat by Genoa Color Technologies, and their position is, if you look at the right side of their image, you can see that kind of pinkish color, and it matches what's on their monitor at the right, but there's the reddish color on the left, and so they're saying, aha, that's why you need our technology, which has 5 primaries instead of 3, except you're seeing that here on this projector that has only 3 primaries. Again, source material matters. Here are some very screwed up Luma equations down at the bottom. In one case, I'm decoding 601 as 709. In another case, I'm decoding 709 as 601. If you can see the difference, you're better than I. Here is something that appeared in the SMPTE journal in the November-December issue, what we learned at the annual conference. This is by Barbara Lang. She said, the overwhelming response from attendees was that faster and better pixels are more desirable. And from the EBU UHD roadmap at IBC, 4K, limited viewing range, maximum 1/2 grade impact, higher frame rate, higher dynamic range, wider color gamut, and immersive sound, no limit on the viewing range, and seems to be higher impact. And then there's the post and pre-compression data rates. So, any questions? Eric?
So in some of these cases, what would need to be changed necessarily to get the higher dynamic range or the higher frame rate? Like, for example, you're saying the consumer TV, some can already produce much more brightness.
Yeah, it's a very difficult thing for me to describe because you don't have it here, but if you can possibly get to one of the Dolby demos that has 4 screens, that will be significant. What the 4-screen demo is, one of the screens is their PRM 4200 reference monitor, which will go up to 800 nits. One of the screens is this Pulsar special water-cooled monitor with ultra high-intensity LEDs that does 4,000 nits. But the other 2 screens are 2 identical Samsung displays, consumer TVs. And what they show is on one of the TVs, material that was graded on a 100 nit monitor, the standard reference that we use today, and on the other TV is the same material but graded on the 800 nit monitor. And the difference between those 2 identical TVs with identical brightnesses is dramatic. You see much more detail in the one that was graded on the higher dynamic range monitor. So that's something that's fairly easy to do. Just go to a higher dynamic range monitor. They're available from a number of sources. Dolby isn't the only one. 100 nits is kind of from a long, long time ago. Yes, Merrill.
Yeah, just a comment with respect to the higher frame rate. While you're showing it as pure integer multiples of the initial frame rate, with compression, that may actually not be the case. Because as you put the frames closer and closer together in time, the changes from one frame to another become smaller. And so the compression, you're using a lot more B frames, the compression can become a lot more efficient.
Yeah, that's why I emphasize the fact that I was talking about pre-compression and post-compression data rates. So in compression, maybe the overhead is as little as 5%. We don't know. Yes?
A couple of slides ago, you made the comment, assuming that 1/2 of the LSP is noise. With respect to the cameras, 12-bit or 16-bit, is it the case that only 1/2 of the LSP is noise, or are there some cases where the cameras have 3 LSPs of noise? Or?
Well, it depends on how you set up the camera. You can go for lots of gain or you can go for limited gain. Sony, when they went from the HDC 1500R to the HDC 2500, didn't claim any more sensitivity because they already were very sensitive in the 1500R. But between the 1500, not the R, and the 2500, there's about 12 dB of difference. Now, whether you claim that as freedom from noise because you like your waveform monitor to have a nice skinny line, or whether you claim that as increased sensitivity, that's up to you as in the way that you set up the camera. Yes, over here.
The point that you make about the high dynamic range, there's a corollary there with audio as well, between 16-bit audio and 20-bit audio. And everybody says 24-bit, but actually the difference between 20 and 24 is beyond the range of human hearing. You really can't go that far. But the difference from 16 to 20, it really is huge. And the same point is true about compression. Compressed 20-bit audio will sound much, much better than uncompressed 16-bit audio, with almost any source material.
Again, it depends on what the noise is doing.
Yeah.
You can go to a demonstration where you hear 1-bit audio and it sounds terrific. But given the sloppy way that most people do things, the more bits, the better. Yes, in the back there.
So I'm getting a little bit of deja vu from the first days of high definition, where the monitors couldn't have the same light output as standard def, and couldn't maintain the same dynamic range because of the finer screen and the tighter beam. Are we not at that stage with 4K that the technology improvements, just like they have in HD, in the display level, will overcome most of the limitations you're pointing to here that would seem to indicate that move to 4K isn't worth it because of these limitations?
Well, ignore everything that I've said about high dynamic range and higher frame rate and just look at the resolution. And we have this between 1/3 and 1/2 grade improvement that's on the same monitors with the same source material with the same viewers at different distances. So they're seeing an improvement. There's no question. People who say you can't see HD are wrong, but they're not seeing a huge improvement. So the question is, why are they not seeing a huge improvement? And what I think might be going on is actually on the opposite end from what you're saying. I think it might be those cameras. I think that because we don't really have a true 4K camera anymore since the Lockheed Martin device, it may be that the compromises that are made in filtering and so on to get that source material, maybe that's what the issue is. But at a certain point, we do get to a level where at a normal viewing distance, someone with normal visual acuity will not see a difference. I mean, humor me for a second. Let's say I have a 4K monitor and an 8K monitor and an HD monitor and an NTSC monitor, and I aim them all pointing up, so you have to look down to see them. And I fly over them in an airplane at 35,000 feet. Do I see any difference between them? No, I can't even see the monitors. So there is some point at which the acuity makes a difference, and there's going to be some point at which going to more for human vision isn't really going to hack it. Now, as James was saying this morning, if you got film and you want to see something that happened in the bottom right quadrant of that film, or the bottom right octant or centant or something like that, and you've got the resolution, sure, that's great for doing analysis. But for watching stuff, it's hard to say. Yes, Ed?
To add to that, which was, again, the tech retreat, that's good if you have a static image, but as soon as the guy starts panning the camera, even if he's doing a shaky cam, like on Law and Order, the resolution drops to like nothing, because the camera's sitting there slowly moving, destroying all the details.
Any other questions? Yes.
Is there any reason to believe consumers are actually going to embrace 4K? I was reading a stat yesterday that said something like they think maybe there will be less than 10% penetration by 2020 in consumer space.
That's one stat. Another group is coming out with a stat that says it'll be more than 30%. But it doesn't really matter to a certain extent what consumers want to embrace. If the consumer goes into the local electronics store and says, give me the best TV, then the consumer gets something that has whatever, 4K, 3D, something like that. There's not been any 3D broadcast to speak of. There's not been any 3D on cable or satellite, and yet there are millions of 3D TVs in consumer homes because that's what they got when they asked for the best thing. Yes, Ed? Sorry.
Back to the Dolby monitors, I remember at the HPA retreat a few years ago being impressed by the one with the moving bright areas where they had the...
That's what the reference monitor is.
They're still doing that.
They're still doing that. And that's a commercial product. That's available. The Pulsar is not available. It's hugely consumptive of electricity.
So it isn't... Okay, so it's producing the high dynamic range by being able to control...
Yeah. There have been some tests, by the way, I didn't include in this, but just people seeing what they might want if money were no object. And what they did was they took a digital cinema projector and they projected it on a rear screen about the size of a little monitor. So they had huge amounts of power, and what they found was that for expert viewers, they wanted to go from something like 0.001 nits out to 20,000 nits. And for non-expert viewers, they still wanted to go from something like 0.01 nits out to 10,000 nits.
But in the case of these monitors, like you're saying, the Samsung is capable of 1,500 nits, but it's not doing the moving HDR presentation.
I'm not sure what technology they're using for it.
Okay, so it's
conceivable that they're doing
HDR monitor. It's supposed to be.
It's a high brightness monitor. Whether it's HDR, I'm not sure.
Well, I guess what I'm saying is that more brightness isn't the only thing.
Correct. Any other questions?
How does
Yes.
higher shutter speed, so to speak, or the equivalent of frame rates in the monitors where they double and triple 240 hertz and so forth on displays factor into this?
here is the chart of the EBU results, and notice you have a 60 hertz 100%, 60 hertz 50%, 120 hertz 100%, 120 hertz 50%, 240 hertz 100%. Those 150% are the shutters. So going to half the shutter speed, or going to a shutter that's giving you the information half the time, is actually improving the performance.
So could you extrapolate that out further, that if they increased it up on the display out to 480 and so on?
Well, again, there are interacting things. So if you go to a shorter shutter time, then you're making motion judder potentially worse. But one of the interesting things that the people who are pushing higher frame rate say is that there comes a point, maybe around 120, maybe around 200 frames per second, where motion judder seems to go away. And so then you can make the shutter as fast as you want. Any other questions? Looks like Eric thinks that time has just about done. Okay, thank you very much.